Hello बच्चों, good morning to all. I am Sikander sir. Today I come with properties of a scalar product. Yes, properties of a scalar product. Okay. Today we'll discuss about this topic, but before it, those who are the new students, those who have not subscribed, please subscribe my channel. Okay, and this is the topics that we use, okay, to find or to solve the numericals, because property is very important, and without the properties we cannot apply the formula. Okay, so properties of a scalar product we have already discussed. What is the scalar? A scalar means the quantity which having only magnitude but no direction. Yes, that we have discussed. And vectors which having magnitude as well as directions are called vectors. But you know that whenever we apply the force, whenever objects, okay, or you can say that if the two objects are acting, okay, with some, okay, angles, or you know that the objects are moving, there are so many cases. So first, suppose that if you will take the dot product of two vectors, you know that first dot product of two vectors, okay, obeys commutative law, obeys commutative law. Always commutative law means what? You know that suppose we have a vector A and B, that is the A dot vector B equal to, we can write B dot A. Okay, this is called, okay, this is called commutative law. Commutative means, suppose that you know, if you will remove this vector signs, then you will write what? You will write AB cos theta. Okay, AB cos theta, and also you will write, yes, BA cos theta, BA cos theta. Can we write? Or you can write these ones, AB cos theta equal to, you can exchange this place, so you will write AB cos theta. Now you see that LHS and RHS both having the same. Yes, means A dot B is equal to B dot A, we can write, because whenever we will remove this vector signs, so we can write here AB cos theta is equal to B, okay, BA cos theta, and then exchange their position. So you will write here AB is equal to, AB cos theta is equal to AB cos theta. So this is commutative law. Okay, next you write the dot product of A vectors, okay, the dot product of a vector, the dot product of a vector with itself, with itself give, okay, give the square, gives the a square of its magnitude. Yes, second properties we have, the dot product of a vector with itself gives the square of its magnitudes. And suppose that we have a vector A, and the same vectors you will take A dot A, then you will write what? A dot A, that is the A into A and then cos theta. If the two vectors are acting along the same line, so theta what? So theta, since theta equal to 0, and you know that cos 0 is equal to 1, means A dot A equal to A square into 1. Can we write? Or A dot A equal vector A dot A is equal to A square, or A square equal to what you will write here? You will write A dot A. Can we write? Okay, this gives the square of its magnitudes, and also you can write in the root. That means the A is equal to root under vector A dot vector A. Can we write? Okay. So such type, okay, this is the second properties of the scalar product. Is it clear? Okay, so another are also, you know, that the dot product of two, okay, mutually perpendicular vectors. Thirds, you can take the dot product of two mutually perpendicular vectors are 0. Yes, the two mutually perpendicular vectors are 0. 0 means, suppose that two vectors, one is a, suppose that, okay, vector A is here and this is the vector B, and the angle between them is, what is the angle? 90 degree. In that case, you know that what you will write? Vector A dot vector B is equal to AB cos theta, and you know that theta is equal to 90 degree. So cos 90 is equal to 0. Therefore, you can write A dot B is equal to AB into 0. That is the vector A dot B is equal to 0. It shows that whenever two vectors are acting perpendicular with each other, yes, perpendicular with each other, then what will the dot product of that two vectors will always 0. It means A dot B is equal to 0. It means P dot Q equal to 0. Anything you can take? Okay, means two vectors will always their dot product by making angles 90 degree, it will be 0. Another you can take, I think that you should write these properties. All you have written. Okay, very good. And those who have not written, you can take captures here, because if this side I will erase that only. The next topic we will discuss. Okay, very good. So we have the third, that is the fourth one. Okay, two vectors are collinear. Two vectors are collinear or anti-parallel to each other. Yes, or anti-parallel to each other. Okay, each other means when the two vectors are collinear or anti-parallel to each other, or you can say that if their dot product of numerically equal to their product of their magnitudes. Okay, on that case what you will write, since you know that A dot B equal to, what you will write, A dot B is equal to AB cos theta. But you know that the parallel, in case parallel means what? Suppose that one vector is here and another will also lies, if it lies the same in that, okay, another's in that line, maybe along that side y axis, this will be x axis or any axis. Okay, on that case the theta will 0, and you know that cos 0 1. So A dot B equal to AB cos 0 means AB into 1 is equal to AB, means A dot B vector A dot vector B, what you will write, AB, means when the two vectors are parallel, in that case vector A and vector B are parallel, on that case you can write. But suppose that if the two vectors, if it is anti-parallel, that is the one is here and another is these directions, so vector A and vector B like that, then you will know that you will take theta is equal to 180 like that. Okay, so you will take here A dot B is equal to AB cos theta, and you know that theta is equal to 180. Okay, so A dot B is equal to AB cos 180 degree, means A dot B is equal to AB into minus 1, means A dot B is equal to minus AB can be right, yes. Okay, now you can see that both having same, but here is the negatives. Negative, it shows that it is in the reverse directions or anti. Okay, anti means one is suppose that right side, then another is the left side directions. Okay, so fourth you can write these ones, and you know that. Okay, another we can take fifth one also. What is the fifth one? Fifth one you can take, okay, the dot product of is distributive law. Yes, the dot product of is distributive law. Distributive law means what? Means A dot B plus C, suppose that we have. Then you will multiply this one, means vector A dot vector B plus vector A dot vector C. Okay, so this is called the, okay, distributive law. Okay, this is called distributive law. Distributive law means whenever we have three vectors, then in sequence we can multiply. Okay, that is called the distributive law. Okay, and another things, you know that suppose we have, okay, axis x axis, y axis, z axis, this is the origins, and here indicates, suppose that you can take the cap of I, this is the cap of j, this is the cap of k, means here cap of I represents the direction of O to x, j represents the O to y, k represents the O to z. So you know that whenever here will be same, then what will be? The theta will 0. Okay, it means I dot I equal to 1 into 1 equal to what you will write here? You will write 1 into 1 or cos theta, and you know that theta equal to 0 means cos 0 is equal to 1, means I dot I is equal to 1 into 1, means because cos theta 0, no, so 0, that is the 1, and here is 1 square multiply, so I dot I is equal to 1. Okay, similarly what you will take? I dot I equal to j dot j equal to k dot k equal to 1. It means if the same, okay, vectors will act along the same lines, then their dot products will numerically, that is the 1 numerically, that means the 1 unit. Okay, another, suppose that if here will another it means, okay, suppose that I dot j, okay, so I dot j means what? It will be perpendiculars, two vectors will act, then you see that here is the perpendiculars I dot j means I, or you can write here I j, and what you will write here? Cos theta, because if you will remove, then here will be, but directly you write now I dot j, that means 1 into 1 and cos what? 90 degree. Okay, so 1 into 90, that is the 0, so here will be 0. It means I dot j is equal to j dot k equal to k dot I, anything you can take, so it will be 0. It will be 0 means whenever two another vectors will mutually perpendiculars to each other, so on that case their dot product will 0, but if it is same, then it will be 1. So this you will use to solve the numerical. Suppose that one example I am going to take here, related that ones. Okay, suppose we have your vectors, two vectors you can take. Suppose let vector A is equal to x1i plus y1j plus z1k, and vector B is equal to x2i plus y2j plus z2k we have. So therefore dot product you will take a dot b is equal to what you will write, multiply this one means x1i plus y1j plus z1k. Can we write? Yes. And here is the dot product. So you will write this one x2i plus y2j plus z2k. Can we write? And you know that according to this one, if there is the same, so here will be on same case it will be once, and there is the dot product different I dot j, j dot k, like that. You see that, so here will be 0. If you will multiply all the terms, so I dot I this terms here will be x1 x2 into 1, but another you will multiply, so it will be 0. Yes, directly you can write. So directly you can write this will be okay plus y1 okay y1 y2 into 1 again z1 z2 into 1, and if you will take some, you will multiply with this one also, this one and also this one, but you know that all will 0 according to this. Is it clear? So you can write a dot vector a dot vector b is equal to x1 x2 plus y1 y2 plus z1 z2. So this will be the answers, and according to that you can put the value. Okay, how you will put the value? Same process. Okay, so we will try to take some questions. Okay students, revise these questions, that's the important things, and please subscribe my channels. Okay, thank you. Jai Hind.